You're listening to The Solution, a podcast by Growers Mineral. I'm your host, Russell Bobel. In this ongoing series, we will be taking a look at the book More Food from Soil Science, a book written in 1965 by one of Growers' co-founders, Dr. V.A. Tietjens.
Chapter 7. Our commercial fertilizer research program is not tenable. Fertilizer companies were formed on the supposition that every farmer needs fertilizer to grow crops. This was based on the idea that you could deplete the fertilizer in the soil quickly by continuous cropping. From the dealer's point of view, when you form a company to sell fertilizer, you expect not only a comfortable salary but profits for the stockholders. A little arithmetic showed that the potential output of a factory could be very lucrative even if each farmer used only 200 pounds of fertilizer per acre, and many mixing plants were established to assure farmers with a short radius fertilizer when they needed it. Research work was running a bad second to fertilizer salesmen who were inducing farmers to buy commercial fertilizer before much proof was available that the fertilizer was needed. After some 50 years of usage in some areas, research work has lost ground in the race between volume sales and established research facts. The value of fertilizer for producing more crops per acre is still very much confused because the problem is very complex. The early work considered replacement of barnyard manure or supplementing it with commercial fertilizer because there were visions of horses being replaced by tractors, and a more clear-cut division between animal farms and grain farms was in the offing. This has been carried to the point in some cases where we have so many animals per acre that farmers have too much manure for the good of their crop yields and grain farms. Along with the use of commercial fertilizer, there was much discussion about the use of single ingredients. Superphosphate and rock phosphate came in for much discussion as a supplement to manure, and because superphosphate was more soluble, it was considered a better product. We still argue about this. People who are controlled by the fertilizer industry naturally are interested in furthering the sale of the soluble product, superphosphate. Imagine my surprise upon finding a bulletin put out before 1920 by an Eastern experiment station to the effect that superphosphate was toxic to plants. I doubt whether the bulletin was ever distributed. The more I studied the bulletin based on work done by an authority who was a friend of mine and talked with the author, the more I became critical and careful about the use of superphosphate. There probably has been more research on superphosphate than on any other fertilizer ingredient, and we probably know less about it. My humble opinion makes me wonder why we know so little about its relation to nitrogen and potash. From my experience, the interrelationship between nitrogen, phosphorus, and calcium is extremely important in our food production program. My experience is that unless you know what you are doing, there are conditions under which superphosphate may be toxic to crop plants. Since my start in fertilizer research, many fertilizer ingredients have come on the market which have tended to increase the solubility of phosphates, and I think they have confused us rather than helped us. There is no comparison possible between ammonium phosphate and superphosphate unless you know how soluble they are in the soil when they are applied and what effect the gypsum in the superphosphate has in promoting yields. Many of our early experiments can be thrown in the wastebasket because there were too many variables which were not checked. If we check the experiments carefully, we can't help but wonder how much of our research has contributed to the knowledge about what part commercial fertilizer actually plays in our food production programs. Frankly, I don't believe that fundamentally we can give fertilizers too much credit, in spite of the billions of tons used by American farmers. This is not a criticism of their place in our food production program, but it is a criticism of the type of research that has been acceptable during the past 50 years. If one follows the comments in farm journals, items in the daily press, and discussions in national committees and farm discussion groups, it seems that they all work on the assumption that the basis of all crop production is fertilizer, with an occasional side remark that limestone may be helpful. This is a ridiculous assumption which is based largely on propaganda and hearsay. What amazes me is that the majority of our agronomists sit by without a note of criticism. The first year that I was established in experiment station research work, Dr. Wheeler, who was then director of the Rhode Island Experimental Station, told me that it was all right to work on fertilizer, but that I shouldn't underestimate the value of limestone in the soil. I have realized more and more that he gave me more and more work on than any man I came in contact with, and if I were to make one criticism of our early fertilizer experiments, it is that the importance of the calcium ion was overlooked. This is puzzling because of the very enlightening work done by Gans, Way, Hissink, Gedroys, Kelly, Jenny, and others before 1930. As far as I'm concerned, this omission relegates those experiments, including some of mine, to the wastebasket. In my humble opinion, no fertilizer experiment should be initiated until the base exchange complex in the soil is first properly saturated with calcium or is part of the experiment. In my early experiments, I made the mistake of depending on the pH test to tell me the calcium saturation in the soil. Today, my potentiometer is dusty from many years of idleness. Since I have depended on the calcium tests, my experiments have shown results that seem to correlate with soil conditions. Furthermore, I get 40 to 100 bushel yield differences with fertilizers, where formerly I had to analyze my data statistically to find out whether my 6 bushel increase was a significant difference. I am of the opinion that when you have to analyze data statistically to find out whether you have worthwhile difference, you may as well throw it in the wastebasket. We have a lot of statistically analyzed data published in our journals, which has contributed nothing to our knowledge of how to keep our population from starving. There is nothing wrong with statistical methods. They are based on mathematics, a fundamental science. My criticism is that too many of us use them to prove the value of data that was collected from an experiment which was initiated on the wrong premise. Too many of our fertilizer experiments were started on a faulty premise. I have argued with colleagues on many subjects, and I think that they thought that I had radical ideas. One of them told me, "I expect you will agree with the Grim Reaper on your deathbed." In my early years of research, I was quite sure. But as I gained experience and found that I could take corn land producing 50 bushels of corn per acre and increase the yield to 150 bushels with my idea of using fertilizer, well, I became convinced that my radical ideas were on solid ground. Because of my unorthodox methods, I have few county agents, agronomists, and VO Ag teachers listening to me. They say I am wrong, and yet they can't increase yields above 60 bushels on plots where I get 100 bushels or more. I do have a large number of farmers who have taken my ideas and accomplished the same things I have. And when they invite a county agent in to see the results, his only comment is that it won't work. He doesn't trust his eyes, let alone his thinking. There are some open-minded county agents and high school teachers who work with me. It makes a difference where they were educated. For some reason, those who come from Western or foreign universities are more tractable and far more open-minded and seem to be able to do their own thinking. When I taught juniors and seniors in college, I tried to teach them to think for themselves for several reasons. Nothing that I was teaching was so well established that students should spend their time memorizing it. And, secondly, the biological field is so variable that every problem a student faces when he is in the field is relative to something else. I was surprised that so many students wanted to memorize everything. They hadn't had enough training to work things out for themselves. My boss used to give freshmen a talk when they entered college. His theme was, "How adaptable are you? In a changing world, you have to make decisions every day. How well educated are you to make those decisions?" I gave lots of talks to farm groups. I try to give them an educational talk to help them better understand their production problems. In recent years, I hear county agents and fertilizer salesmen who are primed or anxious to get me in a corner by asking me embarrassing questions. I usually direct them by invitation into the front rows, so they will have ample opportunity to ask their questions. They usually sit and listen from 10 to 12:30 a.m., but never ask any questions. One county agent, as he left the room, was heard to say, "I still don't believe him." One fertilizer salesman came to me after the meeting and apologized for having said publicly he doesn't know what he's talking about. Then he added, "I've never heard a fertilizer talk that was so interesting and made so much sense. From now on, if I hear of your meetings, I hope I can attend them. As I said before, my ideas are different from what I was taught in college. They contradict presently held ideas, but every statement I make is based on what I have observed while working with farmers in 23 states. Not all farmers agree with me, and some won't listen to me. They talk with their county agricultural agent, and because he is a government official, they assume his word is gospel, even when they can't grow over 50 bushels of corn with the advice they get from officialdom. Instead of suspecting their methods, farmers are led to believe that they are unfortunate and that they are located on submarginal land. After I spoke to a farm group in southeastern Ohio, a man who looked like a bank executive came up to me. He said, "I am one of those unbelievers. I felt that these submarginal hills, as they are called by the experiment station people, were good for something, and I bought quite a few acres. They are rather steeply rolling, and I started applying limestone and subsoiling around the hills, as you suggested today. But I did it for a different reason. I wanted to stop erosion. I did not think about storing that water in the hills. I put lime on to grow clover. I had always heard that you didn't need limestone for corn." Well, I told him that he didn't if he was satisfied with 50 bushels of corn to the acre. Then he told me he tried growing corn on one hill and harvested over 100 bushels. Since that, he has grown corn on several, and he always gets over 100 bushels. He said, "My experimental station friends come out here, look at my crops, and shake their heads and can't understand how I do it. After listening to your ideas, it is quite obvious why I get those yields. So far, I haven't used any fertilizer. I believe I will start to use some. Perhaps I can double my yield." 5 years later, I visited his farm by accident. My salesman wanted to show me a good field of corn. I heard later it averaged 137 bushels. It was a good yield for submarginal land, and since I saw the field, I know I was misinformed about it. I also heard that the corn in the black ground in the valley nearby only made 71 bushels, but not because of any deficiency. From the appearance of the foliage, I assumed it had been oversupplied with nitrogen. Agronomists have been my greatest hecklers. They seldom attend my meetings. Those who do are usually friends of mine who are open-minded enough to want to learn. I have talked with agronomists who give you the idea that all knowledge comes from them. I know farmers who have more common sense than some agronomists with doctor's degrees. If a person feels that he is through learning when he has a doctor's degree conferred on him, he has lost his usefulness to society. If his education has done him any good, he should be humble and be more eager than ever to seek the truth. I sat in a lecture at Harvard University on personality and reward, and I heard the following statement made. "The unfortunate result of granting doctor's degrees is that so many graduate students make a worthwhile contribution to science in their undergraduate years. But after they have been granted a degree, they seem to forget their obligation. You never see any further contributions bearing their name." I have thought about this a great deal, and I wonder whether there may not be an explanation other than that inferred by the Harvard doctor. I had a man in my employ who had finished all his undergraduate work for a degree from the University of Minnesota, but had not finished his thesis when I hired him. He was very humble in his thinking. Some people said he was lazy, but I did not agree. He had what I thought was a really new approach to his field of major study. It was quite different from his material for his thesis. He had lost interest in his thesis because he became so enthusiastic over his new approach. I spent a good many hours discussing this baby with him. Because it was a new approach, it overwhelmed his thinking by opening up many new avenues of approach. I practically stood over him for 2 years before he finished his thesis so that he could qualify for his degree, and I'm doubtful whether he will ever publish anything along his new way of thinking because he has gone into extension work and probably won't have time on the ideas that he presented to me. It takes a lot of people to make a world. Fortunately, they are not all alike. If they were, we could not argue. Constructive arguing is educational. But when it comes to fertilizer research, it is easy to get our thinking into a rut. I soon found out that there were a lot of loopholes in our thinking, which in many cases could be used to someone's advantage in the sales field. I approached my first research project with much enthusiasm. This was at the beginning of the 20s. I made the acquaintance of many fertilizer company representatives, some of whom had a very definite idea of fertilizers, while others were simply holding a job. I shall always remember the advice one experiment station director gave to me. You will find many people in the industry. Don't let them influence you unless they know what they are selling. After I got into my own company, I decided that the worthwhile salesman was the man who knew what he was selling. When I first went with the New Jersey experiment station, I was called to a farm in eastern Pennsylvania by a fertilizer salesman. A 10-acre field of horseradish was not responding to fertilizer. I was told it had a creeping disease which started in one corner of the field and was gradually sterilizing the field. Plant pathologists had been working on the problem for 3 years and had found no disease organism. In one row, the 4-inch root cuttings hadn't grown a single leaf, while in the next row, the same size of cuttings had grown into plants 2 to 3 feet tall. The reason they asked me to look at the field was because the grower questioned whether fertilizer could be doing the damage, since the sterile soil spots were appearing all over the field. I asked about the lime on the soil and found the pH was 6.8. This meant nothing to me because I never depended on this test to determine whether lime was needed. I took some soil samples and found that available calcium in the sterile soil was non-existent, while in the good areas there were 100 ppm calcium was on the threshold of being deficient. We corrected the problem by applying 4 tons of pulverized limestone per acre. The disease completely disappeared. I have had many arguments with agronomists about the availability of fertilizer when it is applied to the soil. Some claimed it was 100% available. According to the state chemists, it is soluble, but what happens in a laboratory test tube and what happens in the field are 2 entirely different things. When I got into the fertilizer solution work, I found that it took a lot of stirring over a long period to dissolve a 5-10-5 fertilizer, and the more they pelted the fertilizer, the more insoluble it became. As I got more information from papers published in Russian journals, I found that too much or too little phosphorus could cause mosaic. So I took the fertilizer out of the row, applied it broadcast, plowed it under, and eliminated mosaic. There is more detail on this in the chapter on tomatoes and fertilizer. I never published these results because the director decided that the fertilizer people might not like it. It amazed me to think the fertilizer industry would stand in its own light. In recent discussions, I have heard that they apparently now realize their mistakes and are looking for an easy way out of their dilemma. The nitrogen industry is fast becoming a white elephant. Nitrogenous ammonia and urea and their oxidation products are easily made from the gaseous nitrogen in the air. Many chemical companies are making nitrogen compounds and are looking for sales outlets, and every person who sells them will continue to push them, even if the customer has them running out of his ears. They pay no attention to the customer's needs. They will sell to the farmer who has an abundance of nitrogen in his soil as quickly as to the man who has a crying scarcity. One of the big problems we encounter in trying to increase yields is the abundance of nitrogen in many of our potentially productive soils, which are not producing at the present time. In spite of this, thousands of tons of nitrogen are being sold to farmers every year. This will further reduce yields on a high percentage of the soils high in organic matter. I have had farmers who have high organic matter soil tell me that they are sure that nitrogen increased their yields. When I questioned this, they said they could see it in the greener color and faster growth. When I asked them how much increase in the yield they got, they said they did not check their yield. When I asked them how much shrinkage they had in their corn cribs, they said that it shrank down about 20 inches. When I measure yields, I want comparisons made on a dry matter basis. A bigger ear at harvest doesn't mean more shelled corn. The only sure comparison is a number 2 shelled corn comparison. Farmers have also told me that they knew that they were getting good results from fertilizer because if they didn't turn the fertilizer on at the beginning, They could see the difference in the growth. I was standing with one by a cornfield that was ready to pick. When I asked him to point out 2 such rows, he said, "Sure, there are 2 right down there." And we walked until we came to the 2 rows, in which the stalks were shorter than the others. I looked at them and pointed out that they were dead furrow rows. Well, they must be further down. So we walked some more. We finally came to 2 rows where the stalks were all of a foot shorter. These must be the rows. We looked at them and I pointed out the fact that the ears averaged bigger than on the rows alongside. He said, "That's funny. These can't be the rows." I said, "I think they are, but you should have put a marker here." We couldn't find any other rows, but he was so confused. He said that he guessed the fertilizer was all right. I said, "There is nothing wrong with it, but I am wondering whether it is making you any money. It may give you a little bit more silage." But then he surprised me with the statement, "But I want good ears on my silage corn. Stalks without ears don't make good silage." I told him the only way to make comparisons was to have some check plots next year. Put some stakes in so he knew where they were, and when we harvested them, see how many rows it took to make a load. "Well, I certainly will do that. I can't afford to use fertilizer if it doesn't do me any good." Many of us have the idea that commercial fertilizer on our good land is the only salvation of our future food supply. Applying plant food is only a small part of our crop production problem. Commercial fertilizers, when properly used, can help increase crop yields. But if our experience during the past 50 years is an example, we haven't learned how to use it. Our average acre yields have not increased significantly in spite of the fact that farmers have spent millions of dollars for commercial fertilizer. Even the use of barnyard manure has worked very inefficiently towards increasing yields. One might well ask why. There is only one answer. There are too many complications, and our scientists have been satisfied to conduct their research under very limited conditions. Of course, we should not be too critical if a person approaches his research with an open mind and has the ability to coordinate his work with that done in other areas and other parts of the world. There has been too little integration between scientists. Too many prefer to stay in their own backyard, and I am sorry to say I have found too many ready to look down their noses at work done in other centers of research. We should also mention that we have had too many pressure groups breathing down the necks of research men who are responsible for finding out fundamental facts. I doubt whether many people know the real function of fertilizer. Too many have the idea that if we wish to double our yield, all we need to do is apply twice the amount of fertilizer. Nothing could be further from the truth. Crop yields depend on how efficiently plants can manufacture and store sugars, starches, fats, and oils, which contain carbon. We emphasize proteins, but actually, we need to have the starch-like materials before we can have the proteins. In other words, proteins are made at the expense of carbon compounds in the plant. A bushel of number 2 shelled corn contains 15% water, 8 to 12% protein, ash, less than a half pound, and carbon compounds, 40 to 41 pounds. This 40 pounds represents oil and starch, which the plant makes in its leaves and stems, where the green coloring matter is present. To do this, the plant uses water, which it takes in through the roots and leaves, carbon dioxide, which comes from the air by the combustion or oxidation of organic matter through energy supplied by the sun. What then does fertilizer do? Nitrogen and phosphorus are used in forming proteins, while potash acts as a catalyst, but does not enter into the products in the plant. How does it act as a catalyst? Well, if the facts were known, it is probably radioactive potassium that serves as the catalyst. This is a very minute percentage of the total potassium in the plant, which accounts for the fact that a plant may show potash deficiency symptoms, even though there is an appreciable amount of potassium in the plant cell. Suppose we were to consider the corn crop. Corn is a very important staple food crop. Some work has been done to develop varieties that will grow during shorter seasons. This has shoved our corn belt farther north. It not only avoids the dangers of early frosts, but it has made it possible to grow at lower temperatures. Corn adapted to grow south of our corn belt is another problem. High temperature prevents good pollination of many varieties. Seed corn maggot, weevil, and many other insects cause much damage. We need more attention to heat treatment and storage of corn. This, along with the adaptation of varieties to our southern states, can greatly increase the boundaries of our corn belt east, south, and west. We need more information on adapting varieties before we can do much about finding ways and means of increasing acre yields. This could apply to many of our crops. We have more opportunity to extend our frontiers to the south than to the north. Of course, different crops can be adapted, but to the extent the limits of any given crop will require much more integrated research. Very few people realize the importance of sunshine in our food production problem. We assume it is ever present, that we can't do anything about it, and, therefore, we need not worry about it. Needless to say, if we didn't have sunshine, we would all starve. Even if we should experience a season of an exceptionally high percentage of cloudy weather, we might expect a decline not only in the quality of our food, but in the total quantity produced. So far, we have not mentioned the potentialities of all our soils. If one travels cross-country by plane north or south or east to west, one cannot help but conclude that we have a tremendous acreage of land which is doing very little in supporting our national population with food, timber, or raw materials for industry. We would also observe that much of the land which is being farmed or has been farmed is not very productive, if the farm buildings are any criterion of the standard of living of the occupants. The level land generally is being farmed, but even some of that is abandoned. We see much rolling land being farmed. There are also many more rolling hills that can be profitably farmed. The question is whether we have the know-how to do it. When most of us think of hills, we think about the lack of fertility, lack of water, and accessibility. If you can't drive a tractor up a hill, you can't farm the land unless you have a mule and one-horse equipment. If you have to farm with one-horse equipment, it may be too costly. We may have to follow the examples of the Chinese and Japanese and farm with terraces. The biggest expense would be to build terraces. We might have to do some government bulldozing as well as applying limestone to hills with helicopters. We won't know for certain until we try it. Many methods which at first seem impractical become commonplace with practice. We have a lot of people living in hill country who could make a better living and maintain a higher standard of living than many now enjoy on level, fertile soil. I have helped people on submarginal hills grow over 150 bushels of corn per acre. These hills were considered too poor to farm. The procedure was to apply 5 to 10 tons of limestone per acre, and then, when the ground was dry, which it usually is in July and August and later, subsoil the hills crosswise to the slopes. This means pulling the subsoiler in circles or ovals around the hill, starting at the top and continuing to the bottom. 16 to 20-inch deep subsoiling keeps all the water from rainfall on the high ground during the fall and the winter. It will be stored in the subsoil instead of running down the hills. Water is stored there for future crop needs. The costs run from $21 to $30 an acre, plus the expense of planting the crop. We have gotten bigger yields on these hills than on some of our very fertile black soils. One secret about this is not to use dry fertilizer. Fertilizer solutions must be used sparingly. 25 pounds an acre on the seed and 25 to 30 pounds applied on the foliage by airplane is usually enough to grow the crop. We can increase our present food supply 3 times by increasing yields. Then we can multiply that by 4 by farming so-called submarginal land which is now idle. And finally, by learning how to integrate all factors which affect our yields, we can increase it still further. We have been confused by our economists because we have a surplus, apparently from using too much fertilizer, when actually fertilizer probably has had little effect in maintaining surpluses. Surpluses are local, and we should always aim toward producing a surplus. Instead of producing surpluses, we are trying to legislate ourselves into starvation. Nobody in this wide world can foretell what would happen if we should have a widespread severe drought. In production, there is wealth. We don't want to produce less. We want to produce more, but we have to learn how to distribute what we produce. As crop producers, too few of us recognize quality. When we sell a crop, we want to sell every particle, whether it measures up to certain standards or not. Farmers should voluntarily sell only the good quality and feed the poor quality. Poor quality may be sold at a much lower price for feed. We can haul it back to the field to rot. Nothing annoys me more than to buy a basket of supposedly good apples and find over half of them so poor that they go into the garbage can. A grower doesn't realize how much damage he does to himself by such tactics. If the apples had been sold as seconds or culls, there would be no comment. Even in marketing grain crops, a lot of grading can be done. I have heard mill operators compliment farmers on the high quality of their shelled corn, wheat, and soybeans. That means that they handle a lot of low-quality grain. It would not be difficult to require farmers to sell their crops on a quota and equality basis. To avoid surpluses in the future, there is much that can be done in shifting more acreage to different crops. I know farmers who were raising only enough feed for 40 steers on a 4-year rotation. By gradually changing meadow and pasture to corn acreage, they are now feeding 240 head of steers, and instead of reducing the crop yields, as several agronomists with doctor's degrees predicted, their yields have increased on continuous corn ground. The fertility level in their soil has gradually increased, while their fertilizer bill has decreased. We have lulled ourselves into a feeling of security by assuming the crop rotation was a necessity, and we have shut our minds to new facts gleaned from fundamental research. Too many of us assume we know all there is to know about a subject and thus can't see the future possibilities. Too often, radical types of research are condemned by supposedly educated people, and progress is set back 50 or more years. Our colleges and universities are to blame for this. We made more real progress before our educational systems became so well organized. Too many educators in commanding positions stop thinking when they are put into executive jobs, and everything that comes along which is not in line with their thinking is the bunk, as one man expressed it to me. I was in educational work for many years, conducting and supervising research work, and I hang my head in shame when I think about some of the weak sisters who are responsible for formulating and supervising research programs. It seems as though their minds stop working when they are hired for the job. When I changed from university to commercial work, I realized how weak many of our university people are. Fortunately, we can single out some who are the exceptions to the rule and are making real contributions.
Thanks for listening, everyone, to this episode of The Solution. If you'd like to learn more about the Growers Program or anything you heard in this podcast, visit our website at growersmineral.com. Make sure to subscribe so you don't miss another episode. Thanks. We'll see you guys in the next episode.